at some vector past paper questions then. Okay, so let's find the resultant vector of 2u minus v when u is minus 235 and v is 0 minus 47. So 2u minus v, so that's just going to be 2 times vector u, which is minus 235. Take away vector v, which is 0 minus 47. So that's going to be minus 4, 6, 10. Take away 0 minus 4, 7, which will just give me minus 4, 10, 3. Okay. Past paper question 2 is just looking at the diagram to find the coordinate in 3D. So write down the coordinates of B and C. So it says that the diagram shows a cube. So cubes have all sides the same size. It's placed on top of a cuboid. So it's just a bit of a puzzle to work out the sides. So if I want to get the coordinate of A, which is 846, I had to go along a length of 8, a breadth of 4, and a height of 6. So if that breadth here is 4, it means that one side of the cube is 4. So that's also going to be 4 there and there. Okay? So to get the coordinate of B, I'm going 8 along the x-axis, I'm going 4 along the y-axis, and then I'm going up 6 and then 4, so it's going to be 10. To get the coordinate of C, I'm not going right along the x-axis this time, I'm only going halfway, because it's 4 from here to here. So I'm going to go 4 along the x. I'm not going to go along the y because I'm at the face of it, so it's going to be 0. And then I'm going to go straight up to the very top of the z-axis, so it's going to be 10. So C will be the coordinate 4, 0, 10. Past paper question 3. Find the magnitude of R. So I want to find the square root of 24 squared plus minus 12 squared plus 8 squared. So then let's just work that out. So 24 squared is 576 plus 144 plus 64, which will give us the square root of 784. And we can find the square root of that on our calculator, and it gives us 28. And finally, past paper question 4. In the diagram below, vector RQ and PQ represent the vectors C and D respectively. Find PR in terms of C and D. Okay, so to go from P to R, let's use the vectors we already know. So that's the same as going from P to Q, which is vector D, and then from Q to R, which is against the grain of vector C, so it's going to be vector negative C. So I can say that the resultant vector, PR, is going to be vector D plus vector negative C. So that's going to be D minus C. Okay. Then part B, it says the line QP is extended to T. So all we've done is we've taken this line from Q to P and then continued it on to get to the point T. TP is the same as PQ. So straight away I can tell you that that is also going to be vector D because it's the same size. V is the midpoint of PR, so it's going to go halfway along PR. Express TV in terms of C and D. So to get to that, I can say that TV is going to be the vector D, which will take me from T to P. And then I'm going to go halfway along the vector PR. Now, thankfully, in part A, I worked out what PR was. In part A, I worked out that PR was D minus C. So it's going to be vector D plus a half of the vector D minus C. So it'll be vector D plus a half D minus a half C. Just multiplying out the brackets. And then simplify. So that's going to be 1.5D minus a half C. Okay.